Hey guys, today we have a very talented architect named Sam Cho. He's been involved in iconic projects such as the Hong Kong West Kowloon Terminal, the Hong Kong Airport Concourse, and projects such as Star Vista in Singapore. He is a pioneer in using a technique called parametric design, where he used complex algorithms to solve complex 3D problems. He's also involved in a lot of research involving 3D printing, city virtual mapping, as well as virtual rendering of real estate spaces. So let's hear what he has to share with us today. Okay, hi everyone. Welcome to another episode of Urbanzoom Talks. So today we have a very special guest, Sam Cho, who's actually my younger brother. But in my view, obviously I'm biased, but he's actually a very, very talented designer. Firstly, an architect, and these days he's moved on to other product design, furniture design, interior design. So I think he has a lot of very, very interesting research and projects to share. So very glad to have you, Sam. Okay.
Yep, thank you.
Maybe just a quick one, like just to tell the viewers like roughly who you are, your career so far and all that.
I graduated from NUS, and then after that I went to Hong Kong.
You graduated at NUS doing
architecture.
Okay.
Yeah, and architecture, and then I graduated from NUS and then I went to Hong Kong in ADAS. I did a few big projects.
ADAS is an architectural firm.
Yeah, right? ADAS is I think the second or third largest architecture firm in the world. And then after that I went there to become the head of parametric design, meaning digital design, head of digital design. And then been there for 3 to 4 years doing all the Hong Kong big projects in the government.
Such as?
WKT, which is West Kowloon Terminal, which is the highway terminal that link to China. And then the airport Midway Concourse, the airport extension in Hong Kong. And then we also did the Macau Hong Kong Bridge, the station. And then we also help out in the ferry terminal. So basically in Hong Kong that time there is 10大建筑, the 10 biggest architecture. And ADAS happened to be involved in 4. All the projects that is ADAS involved, including those in China, I was actually part of it in terms of helping out with the digital aspect of it. So, well, nowadays, what is not digital? Everything is digital. So, everything that is advanced or everything that is difficult to do, my boss will ask me, "Hey Sam, do this, solve this problem." Then we just go and solve lah. So, airport happened to be quite difficult, and then the highway speed train happened to be complex geometry. And then we won quite a few competition called BIM, Building Information Modeling, which is actually representation of the digital model with the physical model, or physical build model, physical build project. So we did a lot of award on those.
Okay, so you were there for 3-4 years, and then after that?
After that I went to set up a company in China. And then doing on BIM. And
BIM again is building information.
Yes, building information
management. Is it
modeling?
Modeling, sorry.
Yeah. Okay. Building information modeling. So building information modeling is actually a branch of architecture which we actually model it precisely as information. So you can actually very quickly know how big is your room, how many window schedule, door schedule. So as you know now we are on the information stage. Everything that can be organized can be useful. Information that can be useful can be business. So that's how the idea of business modeling is done like that. So we talk about building information modeling, we also can talk about modeling information business. So how do you make use of information from the model as a business? For example, solar wind system, how much is the door, how to maintain and stuff like that. So building information modeling is about that. So I set up a company of that. And then I went on to teach in Huazhong Keji Daxue as an associate professor in a university, top 10 university in China, in architecture firm. Then teaches for about 5-6 years now. And then now I become a department head in another university. So I've been teaching around in China for 10 years already.
But the teaching is always on the side, right? You
yes.
have this, okay.
I mean, it's actually the same. Since I graduated, practice and academic is the same thing. I do parametric modeling. I teach parametric modeling in class. So it's like, okay, this you guys, you can use this technology in actual project. Instead of just teaching like, oh, you can do this with your software, which is boring. We actually use like actual implication in project and tell them, hey, student, you actually, you have to learn this because when you graduate, when some of the bigger company hire you, they expect you to know this. So that's a change, that's a shift. 10 years ago, it may be a new thing. Now, I think anyone graduate without that skill, I expected to know lah. Yeah, expected to know lah. Anyway,
Fair.
yeah.
Okay, cool. I'll definitely get into a lot more details into like the whole how the things in the industry have changed. So to start, but I do want to start with maybe just pick the one project that at least I know that you're heavily involved in, the Kowloon project. Can you talk a little bit, because I remember at the time, I guess this is more than 10 years ago now, you were still a very, very junior guy. You just joined ADAS as a almost like a fresh out of school. And then ADAS won this project, right? And what happened after that?
Well, basically, the point of time, in terms of architecture, architecture is actually a very old profession. Car, airplane, train, modeling of those stuff, right, actually needs a very complex modeling system, which that point of time architecture doesn't have lah. Architecture is done by hand drawn maybe 20 years ago. So you can imagine architecture is actually a very old profession. And then from this project, this form actually is so hard to describe. The complexity of it is actually like a car. So you cannot model this thing, you cannot draw this thing with a hand accurately.
So I'm curious, so like how does the actual awarding of contract go? Is like, so from a layman perspective, right? So I assuming the head architect draw some stuff.
Architecture is actually a very accurate science, like describing the building. Your drawing actually need to describe the building as exactly as you could with the
when you say
technology.
as exactly is like to a few cm
to the mm.
to the mm.
So
okay,
each
millimeter.
of the panel we actually have all the schedule. So that's why information modeling come in. So imagine this building that looks like this complex or this product. Every books and nut, everything you need to describe it as it is lah. So what I do was to rationalize this building firstly. So to describe the geometry step by step, like IKEA document. So IKEA actually, when you buy IKEA furniture, tell you how to assemble it, right? We actually have a document that describes this building step by steps in terms of modeling. So firstly you draw this curve in space, and you use this script, and then you describe, and then you panelization and stuff like that. So that is actually what you do. Yeah.
So I do want to understand, like when the firm first got the contract, it sounded to me like actually there wasn't nothing too granular. It was just maybe a very, very rough drawing that won a contract. Is it like very, very conceptual level?
So in architecture or in design, there's concept design, which is actually you just do a form, do a general rendering.
Okay.
You cannot.
And the general rendering doesn't have to be precise, like, presumably.
It's super not precise, like to the extent that maybe just the angle it has the stuff, and then away from the angle you actually don't have the stuff.
Okay.
So basically, that's how rendering do lah. So when you win the competition, like, oh shit, how to do this ah?
Okay.
This is actually much more than what we can handle. So basically, a lot of situation happened then. Then I was there to I look at that problem because I think technology actually allows you to look at the problem in a different angle. That's why I say, can we look at technology from the technology perspective? For example, I'm a 3D printer. I look at the world, I will ask question. Well, I will ask question, hey, why the wall is straight? So, isn't it better if it's curved? So if I have parametric skill and I look at the world in terms of architecture, why can't this curve be described more precisely? Why must it on site and then hum down the thing? Yeah.
So I mean, you mentioned the term parametric a few times. Can you explain a little bit more what exactly do you mean by what is parametric?
Parametric actually is like mathematics. X equal to y square. So that or y equal to x square. That actually gives you an equation, right? So x can be any value.
Okay.
So with that value, you can actually change different curve, right? So what happened? Like let's say you draw this model, but let's say I change the height, change the dimension a bit. So that model actually will have a lot of possibility.
Okay.
So parametric design allows you to generate like thousands or millions of samples that allows the designer to choose.
Okay. Do you have any visual examples, to share with us?
Sure.
Like to kind of just illustrate the point.
For example, this is the airport project. This is the Hong Kong airplane project.
So this is a new extension of the
Hong Kong
the terminal,
Hong Kong
is it? So this is the roof, is it?
Yeah, this is the roof. So what happens here is that you can see on the bottom left, it's showing a lot of different types of panels. So that can be parametric. So all this video they're showing, all the panels actually flatten onto the ground. There's about 260 panels, different types .
Almost
shapes.
every panel is unique and slightly. They look similar, but
260 is actually not a lot. We rationalize it already. Yeah.
okay.
So in terms of that, the fabrication know exactly how many panels to fabricate. Yeah.
Got it.
Because we consider this curve and then we divide the curve and then we fillet and then we sort of look at the visual whether it okay. Because ultimately, if you have a complex geometry, you divide it evenly, right? What happens is that you have 1,000 panel, you have 1,000 different type of panel, and then we rationalize it so that it looks okay, the curve is okay, and stuff like that. Yeah. So parametric design, or in this term, the equation was different type of panel onto this surface. Yeah. So yeah.
I mean, coming back to that Kowloon, West Kowloon Terminal project, right? I remember at the time you were explaining to me that the roof is just extremely complex.
Yeah.
And so somehow through parametric design, you managed to, in effect, use equation to kind of resolve a lot of this. So can you describe a little bit of the process, what goes into it, or if you have any visual examples of the process?
Well, basically, first of all, it's called the setting out. Setting out is like describing the geometry accurately. So as you can see here.
So this is still conceptual stage, right? This is still.
This is conceptual. This is the rendering.
Okay.
Yeah.
So it's just a drawing, lah. It doesn't need to be precise, basically.
So what happens is you have fencing out plane. You have the setting out geometry of the angle. So all this control is actually controlled parametrically. So like the angle of the glass in Hong Kong is 14.5 degree. More than that is double glazing. So we need to start from 14.5 degree all the way to 0 degree and then fencing out. And then we work out.
What is double glazing?
Double glazing is like two glass two pieces of glass.
Oh, is it just a regulation thing?
Yeah, regulation.
Okay,
so
got it.
Two double glazing
so
literally
cost.
means affect cost.
Got it.
Literally means that it's double
so these are
the cost.
Additional 3D constraints that ideally, you presumably you have a lot of constraints either because of regulations
all
or
the constraints, structural constraint, regulation constraint, on site. Like whether you construct this thing, you have to wear your socks first before you wear your shoes, right? So that kind of thing you need to have your constraint, Okay. So all those constraints you need to consider when you're doing the model. Yeah.
Okay.
So the model is actually all the way onto the and all the logic
mm?
millimeters.
Oh, okay. So
all the way
millimeters.
to
Okay,
millimeters.
got it. Okay.
And you need to consider
accurate to very, very precise. Okay.
Or consider almost to the bolts and nuts, meaning all the MEP.
What's
fire
MEP?
regulation. MEP is like fire escape. Yeah.
Okay.
Control stuff lah. These are the very jialat one lah. Yeah. So when we're doing this, we actually don't know like what's the correct way of drawing it. So I actually created a method that works for this project.
Without parametric design, how would this be done in the more so-called traditional way then? I mean back then.
Well, back then we hire other people to do it.
Okay.
There's only Frank Gehry who can do it then.
Frank Gehry, okay, obviously. Okay.
So Gehry was the only company that did
Okay.
this kind of building. So actually the company was looking to hire them already.
Okay.
So literally I saved them maybe a few $millions or no,
Okay.
a few hundred or $1,000 million.
Okay.
Yeah, because this is a skill that no one have, or rather this kind of method is very scary at that time. You won a competition that is the most important icon in the city, and
You don't know how to build it.
Actually, if you look at Esplanade, right?
Sorry?
Esplanade, Singapore.
Oh, Esplanade, okay, yeah.
That guy hand drawn it.
Okay.
I think it's quite crazy.
Yeah, okay.
Yeah, hand drawn it is quite crazy.
Hand draw as in every single piece.
I think he used 3D Max, and I think it's very, very difficult. So it's a very the other way was like you actually do the model by hand. So what you do is let's say there's 1,000 panel, right? You do 1, 2, 3, 4 and until 1,000. Because you must draw the first one and then you go to. Let's say you make a mistake on the 13, all the rest is all wrong.
Because it's all interrelated.
Yeah, it's all interrelated. So parametric design actually allows you to generate according to the rule. So as long as the rules is correct, then your model is correct.
But how to? I mean, at that point, since it is so new and you somehow know this.
Yeah.
But who can counter check your work? I'm just wondering.
No one counter check.
Okay, got it.
I counter check, but they can counter check by looking at the model, whether this makes sense.
Okay, sure.
Yeah, so ultimately the models is how they check it. They don't know the script. If I make a mistake in the script, basically no one can find out.
Because I mean, it seems to me that it was a pretty interesting juncture where you have a huge project, one of the biggest in Hong Kong. The firm got the project.
Yeah.
But it turns out to be technically super hard to do. And then you, a young punk, fresh grad from school, kind of solved it single-handedly for them with this so-called new thing called parametric design.
Yeah.
How was the perception among the management? Like,
I need to convince the boss. I show them. I have a few lecture in ADAS or in the school. What I told them was efficiency. Can you draw 400 staircase in 15 minutes? Who can draw 400 staircase in 15 minutes? I can. I can do it with this script.
Okay.
Yeah, and then
at the time, are there other people in the firm? Because ADA is such a big firm, right? Yeah. Are there other people in the firm who are
starting to look into? They're all my students.
Okay. Oh, okay. Yeah. So really, the more traditional people who actually with the experience is a complete different paradigm. They really mostly
in Hong Kong that time I'm the only one who do it in practice. There's someone who teach it in Hong Kong U.
Okay.
And we become like partners, collaborators. Okay. And that's how after I went to teach in Hong Kong U, I went to teach in Hong Kong Chinese U.
Okay. Yeah. And all this parametric design thing.
Yeah, we just go in school and teach. And then I teach, and then after that, hey, we hire you. You have the school, right?
Okay.
And then after that, we have students. Then after that, I'm no longer like the only one. I have like junior. Yeah.
But throughout the firm, I guess to me, I think it's great that, because usually technological big leap in innovation, usually it's quite hard change, especially for senior management, right? But in this case, I think it makes sense that what you're saying is that you can literally quantify the benefit, that the cost savings in terms of real cost and also time, I suppose.
Yeah.
And so after you convince, but I guess it's also a leap of faith on their part to really trust that you can, because this is literally the biggest project, right?
The problem is like, oh shucks man, we have a problem in this thing that no one can solve. Any problem that, hey, I can solve this problem, like, hey, this guy can solve, let's give them this. I was actually in this project, I was just doing the bridge, the staircase, and then I solved that in one day. And then, hey, this guy quite good, let's give him another staircase. And then the other staircase, because it's the same script, I think I solved it in 3 hours.
Okay.
Then, hey, this guy quite fast, let's do it, man.
What would it have taken a normal person to do, like using a more traditional route?
Well, about a week.
A week. Yeah. You did it in 3 hours. Okay.
Because that one is the same script.
So for that project, right? After you so-called resolve a lot of this for them, how I'm curious to know, as an architect, how deep will you go into during the actual construction process? Are you still involved, or?
Yeah, all the way into construction drawing, all the way to site.
I see.
So when
the contractor company will actually liaise regularly with you guys, get the drawings, and then figure out.
After I got off from ADAS, they actually called me and asked me a lot of parameters until a year or so. So after I get off from the company and start on my own, I will occasionally receive call, hey Sam, we got a problem of this, can you explain this logic?
Okay.
So all the logic, years ago, we wrote on a piece of paper. So we need to tell them.
So how does it feel when you go and visit the actual thing now?
Well, to be honest, I think architecturally there's some problem. I think there's some problem.
Okay.
But I think in terms of the change in the system, because it was the first Hong Kong project, the government must have a BIM model. So we hand up a BIM model. And it changed.
A BIM model, again, is all the data, metadata information regarding different points of the building.
Yeah. Okay. So all the data. So you can only describe that model that way. So in terms, when we do that, it actually changed the whole Hong Kong environment. One is all the university students, hey, this guy Sam, he actually did this. Because, I'm a new guy, but to them, I'm just anybody. With someone who have this skill, right? And this skill is not terribly 10 times the difficulty. It's not rocket science. It's still simple scripting. So theoretically, anyone with a science background can do it. So they were like, hey, this guy do it, why can't I do it? And then a lot of companies started, hey, we also start this BIM thing, we also start this parametric thing. Because that time was parametric were only used for rendering, getting the effect. I want this effect, and people do it. And then I happen to be at the spot that I must do this one parametrically.
Because the hand drawing way is way too long, and
we have a project that we hire a German architect for 6 months to do a rotation building. He did by hand on CAD, But then when we actually need to
On
submit,
CAD, on CAD,
CAD,
okay.
and when we need to submit, the height change. and then he was like, "Oh God, I'm not gonna do it again," because it's quite crazy. I mean, it's quite crazy. You need to figure out everything, But for me, wow, you change your height, you can change whatever you need. Just I mean, as long it doesn't change my parametric model, I don't need to do it again. I just need to,
Got it. I see. Okay, very interesting. You also were doing this Star Vista, right? The one in
Star
Singapore.
Vista, this one.
How was it? What were your involvement there?
Well, it's also on the modeling. And then we also did the design. So the design team, and then we actually do each floor. This one is actually more problematic in the structure point of view. There's a boat, there's a very big theater on top, 5,000 people theater on top, and then under there there's a retail, and we actually did the whole modeling and all the scripting for it. So basically, I think it's also one of the earlier BIM recipients in Singapore.
Okay, got it. And so in this one, like, is there any like so-called parametric aspect that you had to do, or
all the aliasing in 3D? Aliasing. That means
what's structure?
Structure. People need to draw all the structural model. Architecture need to it's all about coordination in the 3D space, MEP and all the stuff in 3D space. We actually did a crash like test analysis in 3D. So all this the model is actually very useful if you are going to look at the problem in 3D. Especially for the top part, the bow. There's a very interesting skin. That's done parametrically.
Cool. Okay. So I guess you were in ADAS for like 3-4 years, and after that you decided to kind of go out on your own. And why do you want to, quit that gig?
Well, I think I've done enough in Hong Kong at least. I mean, Hong Kong, that time, 10 of the architecture project I did, four of them. Well, it's a bit too much already. I have enough, 3 years. That's what I thought. Well, I mean, I could either set up my own firm in Hong Kong and just do parametric, or I can go China and try to venture. I think China have its own, because when I was teaching in Hong Kong U. I teach in Macau University, Macau U. I teach in CUHK, Chinese University. I teach in Shenzhen U. I teach in Tsinghua and Tongji. So I was thinking,
how were you involved in Tsinghua and Tongji?
Well,
so you just occasionally go up?
Workshop.
Okay,
workshop is like a holiday weekend or something like that.
So the architecture department there will ask you to go over, right?
A week, something like that. I have to apply for.
It's all related to basically sharing about parametric design.
Workshop is actually, teaching is actually the way they teach. They do like, I can show you. Let me see, where's the video. This is a Shenzhen University workshop we did. So the student, and then we did a workshop. I brought 8 teachers from Hong Kong every weekend to Shenzhen U to teach a module. So there is like a lot of logistics. From Hong Kong, go there Saturday, can come back. But it was quite fun. I mean, 8 of us, 2 teachers in the team, 4 teams, about 100 students, and then each of us are really rigor into looking into parametric model. So
what are we looking at? What is this?
This one is a sculpture, a pavilion that doesn't have any bolt and nuts. So each component is a component generated by 3 point of forces. So when you sit on this thing, the forces actually just from this 4 point it will go down directly. The form itself is called vernacular form. Vernacular form is like the form that when you hang a string, it will become a string. So that theory actually come from Antonio Gaudio, where he actually hang the hanging structure. This is actually a hanging structure form in terms of 3D. We upside down it, and then you can see this sculpture going up. This is the vernacular form. The bottom is the pulling forces, and then each of these unit doesn't have bolt and nut. They sit on top of each other. So
it's like a 3D origami.
It's actually more complex than origami because all the forces in the model is okay. According to gravity, it will stand on its own because one stack on top of each other. The Chinese bridges, they have a type of bridges called the 8 stone bridges. So 8 stone, and then they it will be stable after you have the last one. Yeah. So this is like 100 stone bridges, like like literally like a few hundred components stacked together and stable on its own. So that is quite fun. I mean, it was gravity was stable, but because Shenzhen got typhoon and then it got blown away. I was like, hey, Prof Cho, your pavilion got blown away. What the fish, man?
Okay.
I was like, oh, okay. So it was quite a fun thing, but it's because in China you can do this. In Hong Kong, it's like those workshops, you have small model. Yes, it's quite detailed.
Okay, I'm curious. I mean, now that you mentioned China, like, so you're saying that it seems that only in China you have that kind of opportunity to do certain project of certain scale. You know, can you? I mean, and you've been there for what 6-7 years now.
Yeah.
Can you describe some differences, like, on so-called opportunity and also like
China opportunity is a bit overwhelming lah.
Overwhelming.
Yeah.
Okay. In what sense?
If I talk to my peers in NUS now, the project they do may be very detailed, they're very good at certain things.
Like what?
Like for example, I have a peer in ADAS that do airport for 20 years.
Airport.
Yeah,
okay.
Airport only. So can you imagine his life? He's only good at airport, and he can only do airport. So that's not the problem. But I think for my take is that in China you actually got all type of problem. We got hotel, offices, retailers, and the scale that we have is very, very huge. Well, the good thing is we have a lot of opportunity.
What do you mean by huge? Like, can you give a sense, like, concretely? What's a typical size?
2-3万方啦.
What is that? That's like
20
30,000 square meter.
Yeah.
Okay.
Yeah.
And that's a typical project. So that would be like the size of what in Singapore?
Retail mall, like
Tampines Mall.
Yeah, Tampines Mall.
Okay.
Yeah, Tampines Mall. Yeah. So I think in Singapore it's quite hard to get those projects, or rather, it pay much more lah. At least 5 times or 10 times actually in Singapore. I mean, compared to China, the project we have, because there's a lot of opportunity and risk. So people actually want you to do design, but they will not be such a good client lah. I mean, they you just do and then we just pay you this a bit. Yeah. So we have a lot of opportunity, a lot of risk lah. Yeah. So in China, the good thing about China is that you can try a lot of stuff lah. Yeah. And wow, you go China, everything changes like 6 months or something. Yeah. So very fast. In Singapore, I think it's very, very slow.
Okay. So I guess after 3-4 years in ADAS, you go to China, and what do you set up there again?
Set up a few company. One is called ACID, which is BIM, BIM modeling.
Okay.
Yeah, and then the one that I currently have is a design company. Yeah, called SXO.
Okay.
So basically,
what sort of design you all do?
Well, we do architecture, urban, and then interior. Yeah,
urban. What do you mean urban design? Like city, almost like city planning type?
No, city, not to the city planning scale. Like for example, 小区, like 3,000, 5,000 residents planning.
Okay.
Yeah, 墙牌 lah, it's called. So those are like residential thing, and then we do planning, we submit plans, stuff like that. We do schools. We did a school recently. Okay. So
do you have some like interesting project you want to show? Like
I think there's a website. This is a 200-meter tall tower.
Where is this?
Rugao.
Okay, so you guys do the conceptual design for this one?
Yep. And then this is architecture. And then this is friend offices. Because so many lah. I mean, you have interior, you have sculpture, so it's big scale interior, commercial offices, and then this is a school. Yeah, this is a cinema. This is a sports center. There's a retail. There's a hostel. There's a hotel. This is another one. There's all this yeah we got a lot lah. I mean, the problem is that it's too fast lah. I mean, it doesn't have like you need to solve so detailed lah. People doesn't have that high requirement as in Hong Kong and Singapore. I would love to. I mean, because in Hong Kong, like WKT, the model we did about 500-600 times.
Wait, sorry, what was this? The WK?
Even the high-speed train.
Okay.
We did the model for 500-600 times because it spanned from 3 years project for me lah. So we did a lot of modeling and we did a lot of testing. So it's very in depth. For this one, well, you only have 3 months. So what are you supposed to do? You can only lower your expectation. So because the project doesn't require to do that kind of thing.
Got it.
Yeah.
I see.
Even in this is actually one of the biggest project in that site. Nantong.
How high is this?
250.
250 meter.
Yeah.
Okay.
Yeah. So it's
Reminds you a little bit of CCTV.
Yeah, it's a bit like
Okay.
a lot of people say that.
Okay, got it. I see.
Yeah, but basically like that. So a lot of opportunity in China, which good and bad. I mean, for me,
But besides this, you are always constantly teaching, right? So you were saying in China, you were also teaching in this university, and what kind of research or R&D were you doing on the site?
Yeah, we did a bit of like 3D printing, like interactive 3D printings.
Okay.
Kind of thing.
Well, what is this?
So this is a like 3D print interactive wall. 3D 打印互动墙啦。So what happened is in this thing. It's supposed to be in a shopping center, and then you project the screen. People can dance and interact with it.
So everything here is 3D printed.
Yeah.
The individual components.
Yes. Yeah. So
and how are they being assembled? How big is each piece? I mean, is it roughly
that point of time when we did this project, the more 靠谱 one, the machine that we use is a MakerBot. Yeah, and
what sort of material is it? Is it just
ABS?
Resin?
ABS is actually a plastic.
Okay.
So actually it's everywhere like ABS, like this. I think it's ABS. Yeah. So those kind of material is ABS. So we can do finishing afterward.
I'm sorry. Can I like what is going on over here? Like you have this.
Yeah.
A lot of lines. Can I explain a little
So
bit?
this is actually the sunflower pattern. If you look at the
sunflower pattern. Okay.
If you look at sunflower, it's there's a number to it Yeah. So
a number to it.
Yeah. The rotation of the sunflower. You look at the sunflower code, the rotation actually have a script for it
There's an algorithm.
There's an algorithm.
It can be expressed in a mathematical expression.
Yes.
Okay.
And then we express the mathematically equation geometrically in a 3D software, and then we make that to a wall.
Okay.
Yeah. And then that we use Kinects to interact with people. So people dance in front of it. You have a projection mapping onto this thing.
Okay.
So basically, 3 technology parametric design, and then 3D printing, and projection mapping. Yeah.
Projection mapping. Okay.
So this 3 So we did quite a bit of like this for fun I mean we was doing it for exhibition and for fun So we also have a few competition we won recently that we did like 3D printing. That one I need to find.
You see whether you can.
It's a chair that we won. We did a chair that is like generated from the mountain, so it looks like a mountain
Okay.
It's a chair. We 3D print that chair 2 meter.
Continuous.
Yeah.
What kind of material?
Also ABS.
Okay.
Yeah, but it's quite nice I mean, we won the Beijing competition recently, so we wanted to sell that to the market. Cause when we're doing that wall, that 3D printing is too expensive. So that wall actually costs quite a bit And it's a piece of art. It's okay, but not everybody will need a piece of art, right? So for now, we actually find a 3D printing company that can do this.
Wait, so it's a 2 meter wide continuous piece
of art
that is printed by a printer.
Yeah.
How huge is this printer?
Well, the printer is like this size, this room. Yeah.
So it's like what? Okay, people cannot see. So this room is about 2 meter by 2 meter.
Oh, sorry, I shouldn't say that.
Yeah.
Yeah.
No, you can say
bigger than this room.
It's bigger than this room. The printer.
Yes, bigger than this room. I can show you. I mean, it's quite fun.
Okay.
The biggest thing that we print is what I think is 5-6 meter schedule, like this Mao Zedong.
But can't be one continuous, right?
It's assemble
Okay,
assemble.
got it. I see.
Yeah, but it's quite crazy
Huh.
Yeah. So
really industrial grade kind of printer then.
Because in China you can work with those people. It's cheap. They're also looking for opportunity to work with people. I mean,
how long does it take to print? I don't know, something that's 2 meter long.
About 2 days.
Wow, it takes 2 days.
It takes a while.
Wow, so the alignment, how do they get the alignment continuously well over such a long period of time?
The main problem was if the 3D printing got hit wire halfway, that means you need to reprint, start from beginning. That's the main problem.
What kind of accuracy can they do these days? Like how granular? Like is it a few mm kind of accuracy?
3D printing have three technology basically.
Okay.
Water, sand,
Okay.
and toothpaste. You can think of it like 假膏 toothpaste lah.
Okay.
Toothpaste is like 3D printing is actually layer by layer, right?
Okay.
So toothpaste meaning you have toothpaste, you do like that, and then okay, one layer, and the next layer. So you actually build up. So that is called FDM, that technology.
FDM.
Yeah, FDM.
Okay.
FDM you
It's
can
kind
do.
of like toothpaste. Okay.
Yeah, kind of toothpaste we call it toothpaste technology. Yeah.
Okay.
So the water technology is SLA. SLA is like water, and then you laser them, and then layer by layer. Yeah.
Okay.
And then powder is like sand Then you have one sand, you layer by layer. So different type of layer by layer
Okay.
Yeah. So different technology at different sizes normally FDM is 2 meter, SLA is slightly smaller. And then unless you are really rich and then you will do a very huge one, but or not, it's not possible. And then the accuracy is actually depend on what you need also. Like those smaller machines actually have much better accuracy. Like for jewelry, they do just this size jewelry. Yeah,
Okay.
and it's very accurate.
Got it. I mean, I'm curious, like from architecture point of view, like how is 3D printed mostly used for these days? Is it just to print out a small physical model to as an illustration kind of thing, or?
So this is an exhibition we did in China. Like for example, this form. This form is actually vinyl knot form.
What's that?
Vinyl knot diagram. Vinyl knot diagram. Vinyl knot diagram is
okay.
what it means is that you look at water bubble.
Okay.
Yeah, that is the script is written. So you look at water cube
bubble.
You look at the Beijing Water Cube Stadium.
Oh, okay.
That is actually vinyl knot diagram. So the structure supposedly is very stable. Yeah.
I see.
So with that script, you can actually just apply on the surface So this one, to other people, this one very hard to model. Actually, this one you just model, you just download one human being model and then use that vinyl knot script on that surface. It takes about like 5 minutes to do. So that is actually how we used to do this. And then this red color thing is called motion frozen modeling. What happens is that we have a cube at the middle, stable at the bottom, or circles, a cylinder shape, blow a wind on it around, and then it goes around, right, and froze it. And then that is the form. So basically, a lot of game environment you actually have that. Like Houdini and stuff like that is perfect for that.
What's Houdini?
Houdini is a animation-driven software. So a lot of software, Houdini is actually one of the better one for animation. Yeah, so you look at like all the movie makers, the hair, right?
Oh, okay.
Those stuff. Well, for us it's actually quite premature. We just use the script. People actually study into it. So this form is actually frozen wind like movement. So that's how it's designed.
Actually, now that you mentioned about animation, right? I know you also do a lot of work in terms of like pushing the boundary in terms of rendering, kind of like visual representation of the product, of the architectural product, let's say before it's built. And can you talk through a little bit of like how that has changed, since when you first started, more than 10 years ago?
So 10 years ago, the rendering system like V-Ray and stuff like that is probably take about 10 or at least 30 minutes to do a rendering.
To do a rendering of one single scene, one single image.
So let's say you have all your material set up and all the things set up. You set up, you're ready to render.
When you say material setup, that means you apply a material to a digital surface so that it looks like, okay, this is a wall, this is glass.
It takes about 10 to 30 minutes at least.
Okay.
So when I was using my computer in university, actually it takes like hours.
Okay.
But the better computer can take 10 minutes or 30 minutes. But now it's like live. You can do it
real time.
Like real time.
There's obviously a lot of technical improvement from the game development community, right? People pushing the boundary.
Yeah. It's amazing.
And it seems that, obviously from the design community, people who do architectural design and all that, are also constantly trying to up the game in terms of visual representation of the thing before they're built, right? How much like overlap do you see right now? And do you yourself use like some of these things that the game community will use?
I mean, there's two things to it. I feel very excited for it, and I'm into it. I mean, I play with all those software. I mean,
like
Unreal, Unity.
Unreal, Unity. What are these?
These are game development engine. So in game development engine, the modeling is very different from architecture modeling.
How so?
Like Rhino and
Okay.
SketchUp. Rhino and SketchUp, you do the modeling. It doesn't have crash. To me, it doesn't crash with the material. That means you walk.
No
you walk
physical
through it.
or no physical definition.
Yeah, you cannot open
Okay.
the door.
Okay,
Yeah,
roger.
you cannot fold a granite and this know that glass break and broken. Yeah.
Okay.
You cannot have double player game.
Okay.
You cannot upload this to a game environment. People can play around. You cannot talk on it.
Okay.
So a lot of those functionality is not into it. So
Okay.
those functionality is a game function. So you go in the game environment, you know, you play a game, you have
You
a
can't
lot
walk
of
through
those
a
things,
wall,
lah.
for instance.
Yeah.
Okay. Sure.
So here you can walk through a wall. So which is not very real lah. But in the game
you're right.
environment, in the game environment, you
Okay,
can,
so-
you can't do that lah. But what happens?
And
is-
wait, so what is this right now? This is the what program is this?
This is good for visualization. This is ENSCAPE.
Got it.
Yeah.
Sorry, what's this?
ENSCAPE.
ENSCAPE.
Yeah.
So ENSCAPE, it's what exactly is ENSCAPE? Is it a
It-
is a real time rendering?
It's a real-time renderer. Yeah.
Okay.
So architecture, you don't need to actually let
Okay.
people play into it, ma.
Sure, sure.
Yeah.
You
But
just need to visualize it well.
let's say like for you're selling your houses, you actually want like your sun angle and stuff like that. We can do that in the virtual environment. So gaming in terms of it can do anything lah. It's the tool set that you have is much more advanced or much more different from architecture. Architecture, you use beam, you need to count the table and chairs, count the windows, do the details. That kind of requirement. Game doesn't need to. Who cares about the window details, right? You don't need to do that, ma. Yeah.
Got
so
it.
games environment, it's more of the interactive of it, which is very exciting also. Yeah.
Got
and
it.
the visualization is very real. Yeah.
Okay. So I mean, in your own work, have you actually? I mean, is it more just research and hobby? You're just doing like I'm talking about all the Unity,
Yeah.
Unreal Engine, all this more gaming development environment, or are you actually seeing actual application in your actual work these days, or is it just you're just exploring still? Yeah.
It's like this. I mean, in terms of research, right? Like 90% of the research is wasted one. That means you will not earn any money from that research one, or people pay for it knowing that it's just a research. Yeah. Like for example, you want to talk about game environment, the best research would not be in architecture, would be in like those game developer or the software engineer. Yeah. We are the application, we want to use it. So we look at this technology from an outside perspective. Okay, like 3D printing, I also don't do 3D printing, but I design things for the 3D printing.
Got it.
So I define the application aspect. So constantly we are looking into like parametric, like a certain time ago, until I do this project, right? Until people like me start to do this project with this skill, then they're like, this can be used in architecture. So it's a bit of crossover design. So who knows, game engine will be crossover maybe in another 5 years time. But nobody knows. Like, is it important for for your client to go inside, hold a gun and shoot at other people? Well, it's not important. That requirement is not
Okay.
useful
Got it.
until maybe someone create a need for it. Yeah. So there are people who actually push the boundary a bit, like Kujala and stuff like that. It allowed people to interact and design.
So Kujala is actually a interior design platform. In China, very popular. Okay.
Yeah. So like a lot of designer or people that doesn't learn design use Kujala to design for other people. Yeah.
Got
So it burden that boundary, and that Excel is actually a crossover design with very insight into the marketing needs. Yeah. So we are researching like game engine. Maybe somehow we can use game engine to sell like houses to others. I don't know. Well, that is actually a very up game. Then you need to go into the engine and knows a lot of stuff lah.
Got it.
Yeah.
I also know you did a lot of research in terms of capturing or converting something that's already built back into the digital way. Like, can you talk a little bit about your exploration there?
Oh,
Like, what kind of work
okay,
you've done?
Actually, when I set up my BIM company, we did a scanning of a city.
Okay.
So I first show you the result lah, and then we talk about the technology. So we drive a car around Sanya. So we drove a car, and then this car actually have this thing that scan around the city. So it's called point cloud lah.
Okay.
So what happened
Point
is that
cloud.
Point cloud. What happened is that it generates the city cloud in point data, and then you go back. You need to remodel this back to the city. So that is actually for city wise is actually a very accurate representation. Sometimes too accurate of the city lah. So each wall, can you imagine like 1 million point of the wall? So it actually represents very accurately. The problem with it is the data is too big, and then from that data,
The data's too big. I see.
yeah.
Okay.
From that data, we drive a car, we fly an airplane, we scan the city. After you scan the city, you go back to your office, you take the point, and then you put them together in a model, and then start to model them, like all the windows, or the doors, or the texture and stuff like that, and then make that back into the model, and then that give to the government and see what they can use for it. So basically, that is it, yeah.
I see.
Yeah. And then this is the BIM model that we supposedly do. There's the cost and stuff like that. All the stuff. Yeah.
Okay. But I mean, this so-called point cloud thing, is it like is it actually being used widely? Because I mean, like you said, it seems to me that it's almost like too much data and yet also not sufficient data in order to give a decent representation of the real buildings or real city, right?
I mean, when you look at scanning, or actually you look at any technology, it's about the needs.
What is this thing?
This is actually Faru. Faru is a machine that scans the interior.
Is this an actual
This is
project
actual.
you did?
Yeah, this is the actual scanning.
Is this also the same city, Sanya?
Yeah, Sanya.
Okay.
Yeah, this is Sanya.
So this is literally you guys driving a car, or is this also a plane as well?
It's a plane.
It's a plane,
Yeah.
so you install this thing on the plane,
Yeah.
constantly taking this point cloud data.
Yes,
Okay.
yes. So what happens is that the car will have a GPS, and then when you scan, it patch them together, and then it actually depends on, you have all the data, and then you put them together in a model, and then you start modeling them. So basically, a lot of point, and sometimes too much, sometimes too little. Yeah. But the main point of it is ultimately after what you use for it. Like for example, we scan interior sometimes for structural reasons.
Scan interior.
Yes.
Okay. Structural reason. What do you?
What I say is like your bridge across water.
Okay.
That is very important when you do scanning. Like because if you do that scanning, let's say you move by 1 cm, that's actually a lot in the bridge. They
As
need
in
to
like
know.
if the bridge over time
Yes.
sank 1 cm.
Yes.
And because a point cloud can be
Accurate.
super accurate.
Yeah, super accurate.
Laser could be less than 1 mm.
Like let's say this wall, right? This wall I can scan 1 million points to represent this wall.
And what's the accuracy
In terms
level?
of like
each point.
each point is like
what kind of error rate are you talking about?
0.0. I don't know. This can be very very accurate. Yeah.
Okay.
Less than because in architecture is okay lah. For production, you cannot see already. Why you so accurate?
Okay.
So our model for WKC for high speed train is For millimeters
accuracy. Okay.
For scanning, it can be much higher.
Okay.
Yeah, but there's a different type of scanning. Like for this product you want to scan, right? You can scan until so detailed that all this texture on this thing you can scan. But if you want to scan a bridge or scan a city, then different technology. Yeah.
Got it. I see.
Yeah.
Okay.
So it depends on the need. Sometimes if you use the wrong scanner to scan, it may be too heavy on your model. Yeah. And very troublesome. Like for this wall, I just need 4 point. Right? Why do you need a million point?
Yeah.
Yeah. So that's the thing that we do.
Okay. Cool. Okay. So I guess you've been doing so many like different exploration. Parametric. This is parametric design.
Yeah, this form finding.
Form finding, parametric design. Basically using algorithm to solve complex 3D problems. And then you since then moved on to do actual application to like using say 3D printing to actually, because some of these I suppose shapes or 3D shapes is almost impossible to actually manufacture other than using 3D printing. So you started exploring that. You started doing simulation or rendering of the real thing, and then you will do the backward way, trying to create a virtual model of the real thing. And of course, all this, kind of exploration of game, the intersection between gaming development and what you do as a designer. Like in I guess short to medium term, like what are you most excited about among all these like various things that you've been looking at? Yeah.
I think throughout the career, I realized that through technology, you can do things that other people cannot. I'm quite excited in different ways of technology, methodology. Meaning, if you do a design, maybe in my life, I can only do 100 building. But if I create a method, the method can be used like 1 trillion times. Yeah. So I'm quite interested in the method of design. So there's 2 type of research in my company. We focus on 2 type of research. One is design research, meaning office, you have certain dimension and stuff like that, right? We understand that dimension, the needs, right? That's one type of research. Yeah, like the needs research. Yeah, like hotel, how many hotel rooms, how they orientated, what is good. That is design research. The other type of research is technical research. Meaning what kind of skill, what kind of technology used to, like for example, how do we generate the city? There are actually a lot of ways. GIS, OpenStreetMap.
Well, GIS stands for?
GIS is global. I actually don't know what it is. GIS is for data lah. I actually don't know what it is.
It's geodata basically.
Yeah, geodata. So what happened is that you got all the houses like Baidu 地图 and Google Map.
Okay.
What happened is that all those maps you saw that square, right? It's actually not pixel. It's actually points.
Okay, factors.
And then, no, not factors.
Oh, not
points.
Oh,
points.
okay.
They're actually points.
Okay.
So your program actually join the point together and then know that it's a building and then it's a certain color. Yeah. So if you have that data put in your computer, you can generate the city. So there may be at least 5 or 6 ways that can do it efficiently now this day. Yeah.
I see.
Like you can scan the city, you can generate from OpenStreetMap, you can go around, take a city, take picture, and then generate. There's a lot of way lah. Each way, like as I say, like scanning, each technology is not better than the other, but they have a certain meaning of existence. So I'm quite interested like in how this different technology allow people to do much better than others. Like for example in ADAS in Hong Kong, one person can do like 10% job. That's not because I think efficiency one of them. That's even 10% cannot do what I do because the kind of like accuracy or that kind of detail you cannot be done with what you done last time. So I'm very interested in getting that insight and expressing that insight into the world. Yeah.
Cool. Okay. Very, very fascinating. Certainly I think for people who are interested in like a very geeky way to look at design, I think my brother is really is one of a kind, I really feel. Anyway, thanks so much for showing up today and sharing me all the research and all the best for your career. Obviously, you're my brother. I hope for you the best. But I really like what you do. Keep doing what you do, man. Really cool. Okay, cool. All right, thanks, Luke. Okay, ciao. See you next time. Bye.